Hey guys, so this is my first stream, so you need to give me just a second to make sure that everything is working right. The stream is on a 60-second delay, so it's about 1 minute before I find out if everything is okay. Until then, a little bit about myself. I am a coder. I mainly work on very simple educational mini games, like the one you see on my screen. And we're gonna be coding this one today. Hopefully it goes well. This is not gonna be a very complicated project, and neither will be the ones I will stream in the future, hopefully. But it should serve as a bit of a guide on how to get started with Unity and basic coding. Okay, my minute is up. Let's see what's going on. Okay, I don't think I'm actually... Okay, it says live. Okay, and the video showed up, so that's good. Let me just check on the other site. Yep, I'm also live here. And let's see if I can pop out my chat. I don't seem to be able to do it on this site. Okay, that's not good. And I do think I can pop out my YouTube chat, so that's good. Okay. Let's get started. So, I'm just gonna remove this. I did start just a little bit of work on this yesterday, but I'm gonna redo that. Well, first of all, let's talk about how this game will play. Okay, first of all, the child will be around 6 years old, 6 or 7, I think, and he's gonna be learning basic subtraction. He doesn't know how to subtract numbers bigger than 5 yet, and of course he cannot go under 0. So, first of all, you can see these animal tracks. These all have a highlight within them. This highlight will be disabled by default and will appear only on one. Whenever the kid clicks the right answer from this part, he will be shown a letter over this print, and we have the letters here. Sorry. Okay, like that. So he will get one letter at a time. We are making this for Romanian children, so the letters, the words will not seem familiar to you. But the idea is that it will be, for example, let's say wolf. You will get the letters for wolf here, but not necessarily in the right order. After he has all the letters, these will go away. So including the footprints, and including this sign, and including these buttons. And instead, he will be shown 3 different animals. Oh wait, I don't think the footprints are going away. Yeah, so the footprints will be sticking around. And based on the letters, he has to select the right animal. He will have to do this a couple of times, and then the game is over. Okay, so let's get started. First of all, we're gonna put everything back the way it was and the way the game is supposed to start. So only footprints, no animals. I think I should enable these, but I should disable the children. Okay. We're gonna need our number buttons. and we are going to need our sign. Okay, so the way I usually work is that while some of these game objects will have their own scripts attached, I will have a main script, and I'm always gonna attach that to a script game object, which I put in the middle of the screen. Where you put it doesn't really matter, but I prefer it to be in the middle of the screen. I do it this way because we have a lot of mini games in a single project. As you can see here, I think these are the only ones ready, so these 3 folders, but all of them will be used eventually, and it just helps to have a constant place where you know to look for the main game script. Okay, now that we talked about that, we can actually go and create a script. So I'm gonna look, this is 3.3. I'm gonna create the script here, and we're gonna call it Animal Tracker Game. Now, if you noticed, I have 2 folders in my script folder. This folder is an internal framework I've developed. This framework is very useful, as you will see. Unfortunately, right now it's not available for you guys, but I'm hoping to fix that in the future. So we created our script, and now we're gonna do open C# project to make sure that the solution files get synced. Now I'm using Visual Studio Community Edition. You can use whatever code editor you like. I just prefer this one and prefer this particular color scheme. I find it's easier on the eyes, and when you spend 8 hours looking at it, that's pretty important. Okay, first of all, I really don't like the default structure. I'm pretty sure you can change it somewhere, but I just didn't change it. Okay, now the problem I constantly run into, and I'm not sure if it already shows up, is that when I go to Unity, yep, it already showed up, so it says I have inconsistent line endings. That's usually pretty easily fixed, so what I do will just close the file, open it back again, and there you go, line endings are fixed. So we are going to get started by defining our variables. And the first thing we can define is game object array with all our number buttons. We're going to define a simple sprite sequence array with all our okay, that's not our number 1. And this is not a default Unity class. This is one from our framework. I'm just going to declare for all the 3 numbers, and then I'm going to show you what this particular part of our framework does. Well, first of all, it's a misnomer. It's not actually a sprite sequence. It's more like a game object array. And if we go here and we check on these numbers, you will see it is attached here. It just basically has a list of game objects called sprites. And if you change this current sprite, it will just change which game object is active. Now the code itself is a bit more complex, not a lot more. So you see here we have some properties. We can look up the sprites array. Okay, let me just go to definition. Here you have your sprites array. It can return the current game object. It can return the index or set the index of the current game object and give you some warnings if you do something stupid. It does have, so it's marked execute in edit mode. What that means that this will run whenever you're in edit mode, not just when you run your game. And what it does, if it's an editor, it will try to populate the sprites array. So when I add this script to, actually let me show you. So what I'm going to do is undo everything it does. So see that's a mess right there right now. It's just useless. Okay, so when I add it, it will automatically populate this array. Okay, it will automatically put it on 0. And since it is also since it is execute in edit mode, I can change this and I can see the change live. So this is a pretty useful. I know it's a misnomer because, as I said, it's not an actual sprite sequence, but the problem is that we are using this framework for quite some time now, and changing this would break backwards compatibility. And just because the name is wrong doesn't merit all the work of going back in all projects when you need to recompile them and fix the name change. So we're not going to do that. I'm just going to revert this. Okay, so now you know what that does. So these two variables we defined are going to be these 3 game objects, and we're going to use them to display our numbers. Well, usually I'd define all the variables I think I'm going to need, but for right now this will do. So before we continue, we can add that here. There we go, we add it. And now we populate those fields. Okay, so this is number 1, number 2, and number 3. Okay, that's right. These scenes are not assembled by me; they're assembled by our designers, and they're not really good at naming stuff. They don't know how I'll be using it, so they don't usually name it correctly. I'm not sure. Am I silent? Can anybody let me know? Okay, I need to find out if I'm silent. How can I find out if I'm silent? Well, that's nice. I think I'm silent. I think I have been talking to myself for quite a while now. Okay, no, I'm not silent. That's great. Let me close it because I don't want to be viewing my own stream 3 times. That would be horrible. I'm already viewing it like on 2 separate platforms to make sure it doesn't break. There you go, chat's open again. Okay, we drag and drop those. Now we have to drag and drop these. Well, that would normally be a pain to drag and drop one by one. What we're going to do is, okay, check that they're in the right order. I prefer to use this move tool even in 2D. I find it helps you to be a lot more accurate. Okay, and it also shows on the screen even if the game object you're looking at doesn't have a sprite renderer attached, which is a lot of the time, so it's very, very useful. Okay, so 0, 1, 2, 1, 2, okay. So they're definitely not in the right order. Okay, what we're gonna do is name them. That's gonna make it easier to put them in the right order, and putting them in the right order will help us drag and drop them. Yeah, it would be faster if I would just drag and drop them as they are. Yeah, I made a mistake. But this will be useful in the future as well. We'll know that our scene is nice and clean, and we can kind of depend on that information as we go on. Okay, so this is 4. The name was actually accurate. And here it goes completely backwards, I would imagine. So this is 9. It's not even backwards, it's somehow mixed. I do not know how that happened. Usually it just goes backwards after the duplicates, because that's how probably that's the way they did it probably. So they made these and they press duplicate and they move them down a row, which is a fast way to work. Fortunately, it results in stuff like this. So we have 5. Let's see if we made a mistake. So that's 0, 1, 3, 2, 4, 9, 7, 8, 6, 5. Okay. We have that done. We will just put them in the right order. So this goes up here, 3, 4, 5, 6, 7, 8, 9, 0, 4, 5, 6. Okay, that's correct now. So what we'll do, instead of doing this, which would be a pain, we're gonna press this little lock here. What this lock will do is lock your inspector. So whenever you click something else, this part of the screen will not change. That will allow me to come here and multiple select these and just drag them all over. And since we put them in the right order, they're in the right order here, so we can depend on the information that the position of the game object in this array is also the number, the value it has. That might come in handy, might or might not, we will see. It's also possible that we will just use the name. I'm not sure yet. Okay, we have that. So let's get started. Whenever possible, I try to sorry, lost my train of thought there. I try to avoid using awake because firstly, some parts of the framework we developed use awake to perform important actions. Also, if I need to get something done before start runs, I have an option. If I would use awake, that gives me less of an option. So we're going to be using start instead of awake a lot of the time. And here at the beginning of the game, we just want the game to ask a question. So put question. And now we're going to define that function. Okay, so we know that we're going to be needing 3 numbers. And we know that he doesn't know how to subtract more than 5, so we know that number 2 will have to be less than 5. Okay, I think the way we are going to go about this is we're going to generate the result first. This is actually a Darkhold result. Hey there, Magma Razor. Welcome to the live stream. You're my first viewer. Okay, and to generate the numbers, we're going to be using the framework again. And we're going to use something called randomizer. What this class does is basically give us random numbers based on the parameters we give it. But the other thing it will do is do some useful stuff, like making sure that the numbers don't repeat. Well, it kind of does that because it's made with a rule system, and its default rule is that none of the numbers can repeat. I think we're not going to use that rule right now. I think we're going to use a rule called semi-random, which is kind of a misnomer again. But what it does is numbers can repeat, but it cannot be the same number twice in a row. So it can go 1, 2, 1, but it can't go 1, 1, 2. I hope you love C#. I love C# too. It's a very nice language. It's a lot better than the alternative in Unity, which is JavaScript or Boo. I didn't even try out Boo, to be honest, but I don't really like it from what I've seen. Okay. So, if our numbers are going to be, our number 2 is going to be max 5, that means that our result can be, well, it can pretty much be any number between 0 and 9. So let's go. This is how I create a randomizer with the semi-random rule set. We're gonna have to make a using statement for that, and we're gonna say that it can be, see, I have multiple constructors in there. It doesn't matter. At some point I am going to go over the whole framework, but it really needs some work before it can go public, so I need to remove a lot of stuff that we use that is specific only to us and wouldn't be any use of it for anybody else. I also need to add some documentation tags because the majority is lacking documentation tags. Okay, so this number will be between 0 and 8. We're gonna automatically generate number 2 as well, so let's make another one of these. Okay. Now the difference here, I'm going to be using the same rule set, but I'm going to give it a different minimum and maximum value. So I don't want the second number to be 0. I don't want it to be like 8 minus 0 equals 8. I'm going to go between 1 and 5. Okay. I'm also, I like doing this, by the way. I like separating my private variables from my public variables. Just makes things a bit easier to read. There's this saying in coding that code like the person who's going to read your code is a psychopath who knows where you live. So keeping your code clean is just a healthy thing to do. Okay, we have that. And let's generate it right now. Let's say result equals result random, and this is how I get a random number from my generator. And number 2 equals number 2 random put get random. Okay. So right now we have something like a number 1 minus number 2. We're going to minimize that, sorry, equals result. And we generated these two. So number 1 will be equal result plus number 2. So number 1 equals result plus number 2. And let's write that down. Where is Unity? There it is. Let's see if we made any mistakes. Well, it's giving us warnings that we never use some of our variables, but that's not going to be a problem for long. Well, it gave us one number. That's not what I wanted to print out. I guess the result was 7, but let's make a string representation of the I don't know what it's called. You'll see. So let's say number 1 plus, we're basically going to write out what's going to appear on the user's screen, so we can better check if everything is okay. Here's a tip: everything will probably not be okay at the moment, but we're going to fix that. And this variable we just made is going to come in handy later anyway. So we're going to stop that. I've finished compiling our code. Or did it finish compiling our code? Because that's not what should have been printed out. Okay. Oh, I did. Okay. Yeah. That was a stupid mistake. But stupid mistakes sometimes happen. Good thing this is going pretty fast. Okay. So that seems right. The problem is I don't think it will be right in every occasion. So here's what we'll do. We'll just generate 100. Let's see what happens. Now, some people would say that this is a good place for a unit test. I agree. But these games will be so simple that unit testing just seems like a superfluous thing. Yeah, see, it's not exactly okay, because here our first term is 11 and the child only knows the numbers between 0 and 9. Once again, we have 11, we have 10. 4 minus 4 equals 0. Yeah, they do know that, so that's gonna be okay. Things are going okay, except the fact that the first term is not okay. So to fix that, we could go one out of 2 ways. We could solve it with math, just adjust these maximum values to make sure that it cannot go above 11. But I think I'm just gonna brute force it. It's probably not the best thing to do, but it's gonna work. Just 1 second, because I lost some of my setup here. Let me fix that. That is fixed. And we can go on. So first, we're going to move this into its separate declaration up here. Then we're going to define a new variable. And then we're going to go while. Now, by the way, the reason I prefer to brute force it is because, as you will see by the conditions I'll be writing, it will check that everything is okay, not just the thing that I predicted can go wrong. So it just filters out anything I may have not thought about. Just give me a sec, please. Off there. Okay. So let's check these out. First of all, we're pretty sure that number 1 and number 2 and the result will be okay, but we're gonna check them anyway. Let's make a function to do the checking. I'm not sure if we're going to be needing this, but we're going to add it and see. Okay, so let's make the default stance that the number is good. So we're going to return true. And then we're going to type in all the conditions in which this function should return false. So the children do not know negative numbers, so the first thing we're going to do is if number is smaller than 0, return false. Then the child doesn't know any number over 9. Then also return false. Now, of course, you could pack these into a single condition, but I'm just going to leave it like that. It's not going to be, well, it would be a bit nicer, but I think this is a bit more readable than just packing them in and making a longer if. And also, if the number is 0, but it shouldn't be able to be 0, then we return false again. Okay, and now here we are gonna pack a lot of conditions into one. So if is number good, number 1, and this cannot be 0, or is number good, number 2, and this cannot be 0, or, sorry, I mean, or is number good, number 3, and that's result, and this can be 0. Okay, now what I could do is say that calculation is good equals true. But there's a safer, yes, in this case it would work from what I can see. But there's a lot safer way of doing it. So first, you turn your logic around a bit and you make an assumption. You make the assumption that the calculation you're going to be generating is correct. So we're going to say calc is good equals true here. And then you're going to check your assumption and make it false if it's bad. But for that, we need to negate all these conditions. So we're going to put an exclamation point before them. So if either of these conditions is false, then we're going to make this go false and it should jump out. Okay, now whenever you're testing something that has the option of going into an infinite loop, it's a very, very good thing to save everything. It's going pretty good for now. I think we're gonna start to get some good calculations. Well, actually, some good calculations here because we're not showing them here yet. So let's see if it works. I made a bunch of empty ones. That's probably because this. So we should be negating that, otherwise it just never goes into this file and it just generates a bunch of empty strings. That was a mistake. As you can see, we no longer have invalid calculations. So that part of the code did its job. Now, another problem is that even though I could use randomizer to make sure that the same result never occurs, that would defeat my purpose just a little bit, because I do want the children to be able to learn the fact that you can get the same result using different calculations. And what we're going to do to achieve that is we're going to use a list of strings which will remember all the calculations we generate. So what we're going to do here is add it to the list. And you notice we add the string we generated. It's just the easiest. There are other ways of doing it, but this way is going to be very easy because right here we can check it out. Check to see if this particular combination of numbers was already generated. We do that like this. If it does contain it, then the calculation is going to be considered invalid. So right now we should not have any repeating anymore. I'm just going to take this out because we no longer need it. And what we're going to do now is, until now we just showed our calculations in the console. Now we're going to be putting them on the screen. So let's do that. We're going to say that. See, here are the game objects we'll be using to display them. So we're just gonna go number 1 sprite, and this is how you set which sprite is showing. I'm just gonna go number 1 and then copy it. There you go. And result sprite. Now, as you can see, this is giving me errors. That's because the compiler has no way of, well, it could check, it would have a logical way of checking if these variables are ever assigned, but I'm guessing it cannot be 100% sure since the assignment is here in a while. And it's not sure that these values have a value. So what we'll do is we'll just define an invalid value as default, And this helps because if we ever see a -1, we will know that something went horribly wrong and we can try to figure out what. It shouldn't, but you can figure it out this way. Okay, and now we're going to test to see if that works. I think I didn't save or it didn't compile. Yeah, I didn't save. Okay, it's compiled. Now that warning, we can ignore that. That warning showed up because I didn't stop the game before I went back to Visual Studio, so when I came back to Unity, it started compiling while the game was running, and that theoretically should work. In my experience, it usually screws something up. So, but we just ignore the warning and move on. Let's see if it works. It doesn't seem to work. It doesn't seem to work, and I'm not sure what happened to it. So let's check things out. These are all here. Yeah, it's working, it's just not doing anything. Well, I'm not sure why that is happening. Oh, I know why it's not happening, because when we deleted our 4, we should have left our call right there, because we do want it to occur. We just don't want it to occur 100 times anymore, because we're done testing it. Okay, yeah. So, an obvious problem is that the child can see the result right here. We don't want him to be able to do that. So what we're going to do is every time we ask a question, we're going to disable the game object that shows the results. So we're going to go set active false. Okay, now that should go away. We're just going to, if you see down at the bottom of my screen, this, while that little icon is showing, it means that the compiler is still going. You can press play while the compiler is still compiling your code, but I find that slows things down just a little bit, so it's better to wait for it to finish and then you can go on. Okay, yeah, the result is gone. Okay, the next step is having the child press the right button. So we're gonna check if these buttons, okay, they have a button, a normal state and a down state. We're not gonna be bothering with the down state. As with all my games, you will see that we implement the basic functionality, and the polish, like mouse over and sound effects and other stuff, gets added later. But we do have an issue here. Our issue is that in order... Okay, give me a sec. Girlfriend just came home and my dog is a bit too enthusiastic. So in order for these buttons to be clickable, they need to have a collider, and we're going to be using a box collider. Now you can't see that very well because it's the wrong color for you to see it well, but the collider that hopefully helps. See, at this point the collider is way too small. That's because Unity doesn't know to generate colliders based on children. So we're gonna have to edit this and make it about the right size. Maybe just a bit smaller than the right size, because at some places these buttons are pretty close to each other. Okay, no, never mind that. Okay, the good news is, oh yeah, he's a Labrador mixture with something we're not sure what, but he is big. He is very, very big. Okay, now the collider is the same size. The good news is that all these are an instance of the same prefab, so now that I made our first collider, I can just press apply, and the collider should show up on every button, which it does. Okay, let's put our background back. There you go, we have our background back. Okay, so to do these clicks, I'm using my framework once again. The good news is that while the system I have to do this in the framework is a bit complex, it's basically just a script that gives me with an on mouse down function in it, and it gives me an event to know when that happens. So let's put an event on all the buttons. We're going to be doing that by looping through all of them with a for each game object button in buttons. And we're going to go button, not add component. Okay. Oh, he's not a monster. Sometimes he eats people, but it's okay. It's only annoying people. We're gonna use our quick action to generate the using statement for that, and this just gives me a mouse event called event, and we're gonna listen to that and do button click and generate that. Okay, what this does, and it's pretty annoying, let me just undo, it generates this throw new not implemented exception, which is fine. The problem is that it also adds a using system. Adding using system to a mono behavior Unity script is not a good thing. It can get you into some trouble. You can use it, but I just prefer to delete it whenever it gets generated. Okay, so as you can see, our event has two parameters, the target and the type of the mouse event. And we're going to say if type what this mouse event system script does is just helps me avoid manually writing a click script for the buttons and manually doing a lot of stuff. So it's a useful thing to have. It's also something you can create very easily for yourself, but as I said, this framework will be available to you guys at some point in the future, hopefully the very, very near future. Okay, now what I usually do is either add a private or a non-editable variable that toggles when the user can click stuff. This time I'm going to go with a private variable. So we're going to make this false by default, and we're going to put it in this condition. And we're going to make it true every time our code is done asking a question. So there we go. Now after the question is asked, the user can click. And let's get the, so we know the game object he clicked, which is going to be one of these, but we need to find out the value. And the way we're going to find out the value, we have two options. We can either use the name or the array we have. and it's in the right order. Now I'm going to cheat a bit. I'm going to use the name, and I'm going to use the name in a bit of an inverted way. So I'm going to go if target.name equals button. Okay, but here's the thing. These variables can go away from here. Well, actually, sorry about that zoom. Actually, I don't care about all three of them. I just care about the result. So let's move the result up here. Okay, that's better. And we're gonna not make it equal anything. And we're gonna put it back here that equals -1. Okay, now we're just gonna go button plus result, so we know if he clicked the right button. And for now, we're just gonna show a message. We're just gonna say good click. Back click. And let's see if that helps. Yep, that's a back click, and that's a good click, or more than one. Okay, now the first thing we want is we're gonna think about how this game is gonna work when it's done. And basically it's gonna have a sound effect when you click wrong, and we don't want the kid to be able to click like I just did and start hearing tens of sound effects. So we're gonna make sure that the same wrong answer cannot be clicked twice. This will also help the child eventually find the right answer if he doesn't know it already. And the way we're gonna do that is we're gonna make another list. This one will be a game object list. We're gonna call it clicked. We're gonna we won't initialize it here actually. What we're gonna do is we're gonna initialize it every time a question is asked. There you go. And we're gonna, in case it's a back click, we're gonna go, we're gonna add it to our list. And here, I could move the condition I'm about to write. I could write it here. The thing is that this will execute on every mouse event, and we might not want that. So we're gonna add it here. And we're gonna say if clicked contains our target, and just do nothing, exit the function. So now, and actually I think I'm gonna move this out here just so the user can't click the good answer multiple times either. That could be wrong too, though this issue will be solved later, as you will see, but for now we're gonna solve it by placing this here. Okay, let's go test what we just did. Okay, so 0 is a bad answer and I can't click it more than once. 1 is the right answer, but we're just gonna try these. Okay, so each button works once. Let's clear that. And this is the right answer, and I can't click it more than once, so our code is working just fine. Okay, so now we're gonna check out how our designers did our now let's leave that for a bit later. First we're gonna make our highlights. So let's say we're gonna make, we have the footprint and it has a selected. Okay, okay, we disabled it, that's fine. Let's revert this. Or actually, maybe we don't want to revert it. Okay, we're gonna set up our footprints properly, because if you check a bit, I only have one of my footprints showing, and I have multiple footprints. Now, the way we're gonna do this is we're gonna add, well, it's already added, we're gonna use our simple sprite sequence again, and we're gonna be choosing a footprint at random. For this, we're gonna set up a new array. Let's see if it shows up, which of course it will. It does. It's empty. We're gonna lock our inspector again, and we're just gonna drag these there. I am gonna check the order because it might be important later. So let's check 1, 2, 3, 4, 5, 6, 7. Yeah, the order seems just fine here. Apparently, sometimes our designers get it right. Okay, so now that we have that array, we need a new randomizer to choose one of our footprints at random. I think, no, we're gonna initialize it here. What's nice about our no class is that it has the option to take an array as a parameter, and will automatically extract what numbers it can give us from that parameter, from that array. So we're gonna call it with, I'm pretty sure that at least one footprint exists, so that's gonna be on 0, and we're gonna give it the sprites array so it can figure out what footprint it can show us from there. And we're gonna generate a number. Okay. And then we're gonna go and apply to that number to all of our footprints. So we loop through them all. And go footprint, set sprite index, footprint index. Now, the other thing we will be doing is we're gonna be hiding the highlight, so that thin white line there, we're gonna be hiding that. And the way we're gonna do that is, we know that each of our child game objects has a child of its own. Let's see if this one has one. Oops, sorry, it's locked. I keep forgetting to unlock it, and that can get confusing. Yeah, it does. So we know that it has one child, and we're gonna use the fact that we know that. And the way we're gonna use it is, we're gonna go access its transform and get the child at position 0, which is gonna be the highlight always. And we're gonna go get the game object as setActive false. So this should disable the highlight. Okay. The problem is the highlight is still there. Wonder what we did. Oh, okay. Well, what we did wrong is that we are accessing this game object, not this one. So what we are gonna do is footprint dot current sprite, which should always be the sprite that is activated. Right now, it's gonna be this one. Let's see if that works. Yep, the highlight is gone. Now that we have that, we need to see how our words and our animal names are set up. So we basically have all our names here. Let me enable that so you can see what I'm working with. Okay, so these are the names. And we're going to check out how our signs are set up. Okay, so here we have an array of letters. This will not be okay. The reason is it will not be okay is that I don't know if you can see it here. You probably can. They used this special character we have in Romanian, but they didn't use the same special character in none of the names, even though this one should have it. So those won't match, and that we need to fix that. Okay, what we can do is we can, okay, let's disable this. We can make ourselves an array with all the character names, and that's gonna be under our control. We don't care much about the game object names. It's gonna show up here. Okay, so let's see how many we have. We have 7 animals, so we'll have 7 animal names. And we're just gonna, I'm not sure how to do this. If I should include the special characters or not. I'm just gonna fill in the ones that don't use the special character names. So this one uses it, this one uses it, that's position 1 and 2. Position number 3 doesn't use it. And this one has a special character, it's this one, a T with a colon under it. Okay, a lot of these are using these names. We are going to have to fix that. But I think we will fix that some other time, because I think I have been streaming for quite a while now. And I don't want to keep you guys for too long. So thank you for joining me. And we'll be continuing this project soon. Thank you all. Goodbye.